Welcome to your first lesson of Unit 2. Our main topics today are talking about relations, functions, and slope. So let's start by looking at some definitions. First definition of relation. It is a set of pairs of input and output values. Okay, the best way of explaining that is when we make ordered pairs, x's and y's put together. That, if we have multiple pairs, is an example of a relation. It's simply putting together an x and a y. A domain, or the domain. The domain of a relation is simply the set of inputs or x values. Now we're going to add a little note here. Okay, and our little note is only list the values once. In other words, let's say when you're listing your x's, the number 5 appears twice. We don't write it twice in the list, we just write it once. Next definition, range. This is the set of outputs or y values. And the same little note that we wrote by the domain also applies to the range. And finally, our last definition is a function. This is a relation, but there's a catch to it. Each input is paired with exactly one output. That's the important part. It's paired with exactly one output. In other words, each x can only have one y. If you see an x that has two different y's, that's a problem. So, this last box on the slide is actually the 4 ways of representing relations. This first way is ordered pairs. This is the most common, and it's the easiest for students to grasp because you have put points together before. So anytime you have multiple ordered pairs, it is a relation. The second is what we call a mapping diagram. What we do here is in the input bubble, we list our x values. So if you look at the previous part, we have a -3, a +3, and a +4, but it is twice. We only write it one time. Then, in our output bubble, we list the y values. In other words, 4, -1, and +3. And then what we do is we draw an arrow connecting each x value with his y value. So -3 was connected to 4 when they were in ordered pairs. +3 was connected to -1 in their ordered pairs. +4 was connected to -1. However, +4 was also connected to 3. Yes, there's meant to be 2 arrows. The third method is a table of values. Notice the only difference between ordered pairs and a table of values is we put it into a table instead of pairs. It's still each x and each y together. So it's still -3 with 4, 3 with -1, 4 with -1, and 4 with 3. We just put it in a table instead. And then finally, the last method is the graphing method. Here, we simply took the 4 ordered pairs that we had, and we graphed them. So what we are going to look at next is an example of practicing all of these forms. So this is example 1. I have given you here a relation. I am asking you to write the relation shown below in the other 3 forms. Then state the domain and range. So this form is obviously a table. So if we glance back, first we need to write them as ordered pairs. So we're going to make our ordered pairs. -2 paired with 2, 1 paired with 3, 2 paired with -1, 0 with -3, -2 with 0, and 1 with 1. Nothing fancy, we literally just took them out of the table and put them in pairs instead. The next way that we're going to do this is, according to our little thing over here, a mapping diagram. This is where we get a little trickier. So we have two large bubbles. One bubble, two bubbles. The first one is our inputs. The second one is our outputs. So if we look at our inputs, the most important thing is we don't repeat. And we usually write them in order from smallest to largest. So if I look through my x's, my smallest x is -2. I have one here and here. So that's my first one. Next, I have no more negatives. My next smallest is 0. My next smallest is 1. And my last one is 2. I'm going to do the same thing with the y's. My smallest y is a -3. My next y is a -1. I then have a 0, a 1, a 2, and a 3. And now I need to connect them. My first pair, -2, connects with +2. So I'm going to draw an arrow. Next pair, 1, connects with 3. Draw an arrow. 2 connects with -1. Draw an arrow. 0 connects with -3. -2 connects again with 0, so we got 2 arrows there. And 1 connects with 1 as well. That is a mapping diagram. We put the inputs, we put the outputs, we put arrows between them. The final thing is going to be, obviously, our graph, and I provided you with a graph here. So our first pair is -2, 2, so I'm going to go left 2 and up 2, put a dot. Next pair, +1 to the right, up 3. Next pair, +2 to the right, but then down 1 because it's negative. Third pair, stay at 0, but then go down 3. Next pair, go to the left 2 and stay there. And our final pair, go to the right 1 and up 1 and put a dot there. So those are our other 3 forms: points, mapping diagram, and a graph. The final part of this problem asks us to state the domain and range. So I'm just going to list them down here. Our domain, if we reference back to our directions, is all of our input values. Well, I already made a list of those right here. So all I'm going to do is recopy those 4 numbers: -2, 0, 1, and 2. Range, that, as you can see in our definition, is our outputs. So I'm going to use those guys right there that I've already made a list of. -3, -1, 0, 1, 2, 3. Remember, we did not write them more than once. We only made a list one time. So that is making all different forms of relations. Moving on to example 2. Now we're answering one simple question. Are the following relations functions? To be a function, again, our definition was that each input can only have one output. So our first example is a mapping diagram. All we're going to do is we're going to go down our list of inputs, which are also the domain. These are your inputs, and these are your outputs. And we want to make sure each input only has one partner. -3's only partner is -2. 0's only partner is 7. And 4's only partner is 1. None of the inputs had duplicates. So Is this a relation? I'm sorry, is this relation a function? Yes. Each input only had one output. Let's look at B. So the inputs, okay, just to review, your inputs are your x's. So let's look at our x's. 4 is paired with -1. 8 is paired with 6. 1 is paired with -1. 6 is paired with 6, and 4 is paired with 1. Here's our question. Is there any duplicate x's? In other words, do you see an x value twice? And the answer to that is, yes, we do. Here's a 4, and there's another 4. That's a problem. What that means is the number 4 has 2 partners, and he cannot have 2 partners. So, is this relation a function? The answer to that is no. All right, now, we're going to look at another method to decide if we have functions. This is called the vertical line test. So go ahead and write down the definition. It says, if a vertical line, meaning up and down, passes through more than one point on the graph of a relation, then the relation is not a function. I call this the sweeper bar test. This graph over here to the right describes it perfectly. That vertical line right here touches this graph in 2 spots, right here and right here. If it touches in 2 spots, then it is not a function. So I'm going to make my own sweeper bar. I'm going to draw a vertical line. And I'm going to use it as a sweeper. So this is my first example. It is a circle. If I move my sweeper bar right across the graph, you notice like right there, it's touching the graph here and here. That's a problem. That means that no, this is not a function. Now I'm going to run the sweeper all the way over here. Well, there it's only touching one dot. Touching one dot there, one dot there, one dot there, one dot there, and one dot there. I just swept the entire graph, and the whole time it touched the graph one time. So yes, this is a function. Last one to sweep across. If you start noticing, I'm touching the graph the entire time. However, as I go across, I am only touching the graph one time the entire time. So this is also a function. So notice these 2 types of examples, there's no work to be shown. You're just answering yes or no. So these are meant to be quick and easy examples. Let's look at the next vocab word. A function rule. A function rule as an equation that automatically represents an output value in terms of an input value. Okay, these are now equation forms of functions. Function notation is a notation used to indicate an equation automatically represents a function. And here's your important notation. If you see that notation and we read it f of x, not f times, f of x, that means it is automatically a function. So let me show you how you will see this used instead. This first problem uses y's and x's. Whoops, let me get rid of that stuff. Y's and x's are outputs and inputs. As you can see, y's are outputs, x's are inputs. But when we come over here and we change it to f of x, that is still your y value. But all that means is this equation is definitely a function. And we can use function notation to find answers. You can find f of 1, and that's how you say that, f of 1 They're simply wanting you to take the 1 and put it where the x normally is. And then solve. 3 times 1 plus 2 is 5. What that means is 1 is the input and 5 is the output. They're wanting you to find the output when the input is 1. So we're going to practice that skill on a couple of examples. So here's our example. I give you an equation, f of x equals negative 4x plus 1. And I want you to find me 3 answers. So the first one, f of 3. What this simply means is put 3 in place of x. So it now looks like in my equation up here at the top, it now looks like f of 3 equals negative 4, there's your x, so times 3 plus 1. And then if you need a calculator, that's fine. You're simply typing in negative 4 times 3 plus 1, and you get an answer of negative 11. That's the answer I was looking for. So let's do it again. This time, we're putting negative 4 where the x is. So f of negative 4 equals negative 4 times negative 4 plus 1. Again, all I did was I put the number right there where the x is. Negative 4 times negative 4 is 16, and 16 plus 1 is 17. Last example, you try one. So pause the video, try this one real quick. Okay, let's see how you did. F of 1/2 equals negative 4 times 1/2 plus 1. All the hard part, all that fraction stuff, calculator does it for you. Negative 4 times 1/2 plus 1, your calculator should tell you is negative 1. And hopefully you got that answer right. These are not meant to be hard problems. These are meant to be quick and easy. Plug in the number and put it in your calculator. All right, so turn the page. Last topic of today is slope, something that we are very, very familiar with. So here is what we know about slope. We know that it is rise over run. The new definition is it is the ratio of the vertical change to the horizontal change. Now, when we're trying to find the slope between 2 points, we have a very important formula that you've seen in Algebra 1. And it looks like m equals y2 minus y1 over x2 minus x1. This is a formula that everyone needs to memorize. It will be very important on your next test, and I will not be providing it for you. Let's look at the 4 different types of slope. When a line rises from left to right, we are said to have a positive slope. When a line goes down or falls from left to right, it's said to have a negative slope. All horizontal lines have a 0 slope, which we've mentioned already, and all vertical lines have an undefined slope, which we have also mentioned. So we're actually going to practice using the formula that you have to memorize on some examples. So one thing I always suggest, write down the formula at the top of the page. M equals y2 minus y1 over x2 minus x1. The more you write it down, the quicker you'll memorize it. The next thing I suggest is labeling your pairs. Every pair is always an x and a y, but one of them's 1s and one of them's 2s. This first pair I'm going to label x1 and y1. Second pair I'm going to label x2 and y2. By labeling them, it will keep you from making any mistakes. So, let's plug into our formula. y2 is positive 4. That's a minus sign in the formula. y1 is 7. On the denominator, x2 is negative 2. That minus is in the formula. x1 is negative 3. Don't make mistakes. That is 2 negatives there. Now we're ready for our calculator. 4 minus 7 is negative 3. Negative 2 minus negative 1. Anytime you have 2 negatives, they will both become a positive. So negative 2 plus 3 is positive 1. The only other thing you have to do is make sure it is reduced. This is where your graphing calculators can be handy. If you type in negative 3 divided by 1, you get negative 3. I will accept that as an answer. If it was a decimal, we would hit math, enter, enter, and we would get a whole number back out. Let's look at part B. Label x1, y1, x2, y2. Okay, so y2 is 1 minus y1 is also 1. On the bottom, x2 is negative 4 minus, it's always subtraction, x1 is 3. Pick up your calculators. 1 minus 1 is 0. Negative 4 minus 3 is negative 7. Calculator, 0 divided by negative 7 is 0. So we've done 2 of them together. You pause the video, you try C on your own, and then we'll check right afterwards. Okay, so let's see how you did. Label x1 and y1, x2 and y2. So we start off on the top with y2, which is 1, minus y1 is negative 3. Yes, that's double again. On the bottom, x2 is 7, minus x1 is also 7. Your calculator's helped you out now. If you did the double negatives into a double positive, 1 plus 3 is 4. 7 divided by 7 is 0. When you typed in your calculator, though, 4 divided by 0, you should not get 0. You should get an error message. Anytime the 0 is in the top, like example B, the answer will be 0. When the 0 is in the bottom, like example C, this is when we write undefined. Or yes, I will let you abbreviate it UND. So remember, 0 in the top is 0, 0 in the bottom is undefined. Now, this is with 2 pairs of points. We're going to look at 2 other options for slope. The first option is a table. A table is no different than a pair of points. Just pick any 2 pairs right next to themselves. So I'm going to pick those 2 pairs. So the first thing we look at are our y's. Because remember, this is x1, this is y1, this is x2, this is y2. y2, negative 1, minus y1 is negative 5. On the bottom, x2 is negative 1, minus x1 is negative 3. It is absolutely the same as pairs. You just pick any 2 you want. Calculator, negative 1 minus a negative is plus plus. Negative 1 plus 5 is 4. Negative 1 plus plus 3 is 2. And 4 divided by 2 is 2. Let's look at another one. On this one, let's pick this pair at the end. Again, it doesn't matter which two you pick. So x1 and y1, x2, y2. y2 is 7 minus y1 is 4. On the bottom, x2 is 8 minus x1 is 2. 7 take away 4 is 3. 8 take away 2 is 6. This is where my calculators are nice. You can type in your calculator 3 divided by 6 and get a decimal. And you can hit math, enter, enter, and your calculator will tell you 1/2. All right, last pair of examples and then we are done with this lesson. This is slope from a graph. This is going back to the old-fashioned rise over run that we are used to doing. Here is always your best suggestion. When you are counting rise over run, start at the left point, which is right here. I need to count to this point over here. So, rise is always up or down. In this case, we are going up. 1, 2, 3, 4, 5, 6, 7, 8. Since we went up 8, it is a positive 8. Now we need to go back to where we left off, which was right here. And we need to run. This time we're running to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We went right. It is also positive. Type in your calculator. 8 divided by 12. You get a decimal. You hit math, enter, enter. And you get 2 out of 3. Pause the video and try the next one. Okay, let's see how you did. I'm going to use the same words. Rise over run. We always start left. That would be this one. Now notice, we're going down. That means our slope is going to be negative. So from here, I'm going to start counting down. 1, 2, 3, 4, 5, 6, 7, down 8. The way we show down, negative 8. Now, we ended right here. I need to count this time to the right. 1, 2, 3, 4. If I'm going right 4, right is still positive. So it's only the 8 that was negative. And then negative 8 divided by 4 is a whole number. You get negative 2. So that is the end of this lesson. You can start on your homework if you would like. Otherwise, you will have time in class next time I see you.